Okay, today all of the problems are going to be something a bit more word-based. They still all use differentiation. And so the things that you were doing last time, where you were working out the maximum points and the minimum points, we're going to be doing those but in the context of something else. So I've got a problem here. We've got a river running vertically, and we've got some field, and it's got a fence around 3 of the sides. We've been told that the total length of the fence here is 50 meters. The goal here is to make the biggest rectangular area here. Now I've called the sides x and y, and we can say that the area here is equal to xy, like multiplying them together. But we can do a bit better than that. Let's talk about the lengths of these sides. This side's x, the top side's x as well. We know that the total length of the fence is 50, so 2x plus y equals 50. We're only fencing 3 of the sides. Now, what we can do is we can use this to eliminate one of the letters here. To try and get rid of that y, what we could do is we could rearrange this one. So y equals 50 minus 2x, and we could substitute it in. So area is x multiplied by 50 minus 2x. It's like I'm doing simultaneous equations. Right, let's expand this out. We get 50x minus 2x squared, and that's the area. Right, we want to find the biggest area here. Well, the way we do that is by differentiating. We're trying to find a maximum point, a stationary point. So if I do dA dx, notice that this is a bit like the y in our normal equation. So instead of dy dx, it's dA dx. We're just using whichever the letters are in the question. Well, if I differentiate this, I'm going to get 50. If I differentiate this, I'm going to get minus 4x. And the way we find stationary points is we put that equal to 0 and we solve. So x equals 50 over 4, so 12.5. I suppose that's in meters. Okay, well, we want to find the biggest area. If I put this into this expression up here, it will tell me what area that side length gives me. I think this is a calculator job now. So I'm going to go 50 times 12.5 minus 2 times 12.5 squared. And that's come out as 312.5. So the biggest area I get is 312.5 meters squared. And I get that by choosing a side length there of this. All of the problems are going to be like this. Now, a final thing we could do is we could check that this is a maximum and not a minimum. Well, the way we do that is by taking a second derivative. If I differentiate that, d squared a dx squared. If I differentiate 50, it just goes. If I differentiate minus 4x, I get minus 4, which is negative, it's less than 0, so it's a maximum. Remember that if this is a negative, it comes out as a maximum. If it is positive, it comes out as a minimum. And if it's 0, then we're not going to worry about that yet. But it could be either maximum, minimum, or point of inflection. Now, with all the problems you're going to do today, you're going to have lots of different letters. A lot of them are to do with geometry. Whenever you differentiate anything, you're just copying whatever the letters are in the question. So if this is A, then we're going to get dA dx here. There is a really good example in the book, which I'll get you to read next. I'm not going to do it on video, but if you turn into the book on page 280, it actually starts the page before. It's got a good example using a box. It's quite a hard example, but it explains what it's doing. I'd read that first. The exercise for today that we're going to be doing is exercise 12K. They start off easy. I'm going to give you a link to some nice solutions which are a bit more worked than the solutions in the back of here as well. Cool.